This is recording for this May 2024 OCR paper 4 higher tier. Maybe print off the paper yourself, go through each question, put me on pause, unpause when you're done, and you can see if your answers are correct, and if not, how to do them. Okay, work out the answer to this, write your answer, correct 4 significant figures. So it was cube root. In fact, I'd work out 19.5 to the power 4 minus 18 squared. Click equals to find the answer to that before I divide by 1.45. And then using the answer button on my calculator, I'll get the cube root of the answer. And it is 46.33744.236. Full calculator display. 4 significant figures, 46.34. Diagram shows a triangle and trapezium, show they have the same area. How would you find the area of a triangle? Half base times height, or base times height divided by 2. So base times height is 115.2. And then divide this answer by 2. 57.6. And how do you find the area of a trapezium? Half a plus b times the height. So I'm going to add these parallel lengths first. I'm going to times by the height. 115.2, and then I'm going to divide the answer by 2, which is 57.6. So I've shown here they do have the same area. Okay, we've got 4 numbers are written in ascending order as algebraic expressions. The mean of these 4 numbers is 27. The range of these 4 numbers is 24. Find the value of A and the value of B. So I know that 3A minus B subtract A gives us 24, because the biggest number minus the smallest number gives you 24. Let me just simplify this expression. 3A take away A is 2A, so I know 2A minus B is 24. I also know the mean of these 4 numbers is 27. So I know if I add them together, divide them by 4, we get an answer of 24. No, 27. So I'm just going to rearrange this equation. I'm going to make A and B the subject. I'm going to times both sides by 4. And I'm going to simplify the top at the same time. So if I collect like terms on the numerator, I get 6a plus b minus b disappears, but I've got plus 2b. I'm going to times both sides by 4 to get 108. Then, hopefully you'll notice we have 2 equations. We have 6a plus 2b equals 108. And we have 2a minus b equals 24. This is now simultaneous equations. We have 2 equations with 2 unknowns, a and b. I like to make the b's the same. I'm going to multiply the bottom equation by 2. So I know 4a minus 2b is equal to 48. I also know 6a plus 2b is 108 in the top equation. B's are the same, got 2b, 2b, but to eliminate, I'm going to solve these simultaneous equations by elimination, and I need to add the equations together. 4a add 6a is 10a, minus 2b plus 2b disappears. 48 add 108 is 156. Divide both sides by 10, gives you A is 15.6. Now I know what A is, I'm going to work out B. By substituting, you can choose any equation here. I'm going to choose this top one. So I know 6A add 2B is 108. I know that A is 15.6. I'm going to work out 6 times 15.6 plus 2B is 108. I know 93.6 add 2B is 108. And I'm going to take 93.6 from both sides, which gives me 2B is 14.4. Divide both sides by 2 gives me B is 7.2. So we've got A is 15.6 and B is 7.2. Question 4. A school is deciding on a charity to support. Each student at the school votes for one of 4 charities, A, B, C, D. Results are shown in the pie chart. Pie chart shows the sector for charity A. Twice as many students voted for charity C than charity B. Twice as many students voted for charity D than charity C. Show that the sector for charity B will have an angle of 44 degrees. Okay, so angles in a pie chart add up to 360. Let's just do 360 minus 52 to find out how many degrees we've got to spread between charities B, C and D. I'm just going to start with just calling charity B, well, by representing the amount of degrees for charity B as X. Twice as many students vote for charity C than B, so C would be 2X. Twice as many students voted for charity D than charity C, so it would be 4X. If we add them up together, we've got 7X. 308 divided by 7 is 44. So charity B is the X. Charity B is represented by 44 degrees. Complete the pie chart. You need to line up your protractor correctly. Uh, 44 degrees is here. Connect that up with a straight line. If X is 44, 2X would be 88. So 88 is about here. So charity B. C. For D, it would be 44 times 3. No, times 4, sorry, which is 176 degrees. You can measure that last one, but I can see it is about 176 degrees. You can measure it to check that the rest of your pie chart is correct. 39 students voted for charity A. You've got 52 degrees is represented by 39 students. Calculate the total number of students in the school. I'm going to get 1 degree first by dividing by 52. 0.75, and then to get 360 degrees, we're going to times it by 360, which is 270 students. School asks 80 of the students to choose a new logo from 3 designs, G, H and J. The same results are shown in the pie chart and in a bar chart. Give one advantage of using the pie chart rather than the bar chart. You can easily see the proportions from a pie chart. Give one disadvantage using the pie chart rather than the bar chart, where you can't easily see the frequencies from the pie chart. The same dog food is sold in 3 different size packs. Diagram shows the price of each pack. Which pack is the best value for money? So we need to compare the same value for this. So I'm going to work out 1 kilogram for each one. 1 kilogram. So for this pack, 5 kilograms is £53.90. 1 kilogram, well, we need to divide it by 5. £10.78. Here we have 3 kilograms for £32.50. So 1 kilogram, divide it by 3, £10.80. And this last one, I'm going to get 100 grams first by dividing it by 7. And I'm going to times it by 10 to get 1,000 kilograms, 1,000 grams, which is equal to 1 kilogram. So it is the 5 kilogram. I have kind of explained it as we're working out, but because I've compared 1 kilogram of each packet, of each pack. And the 5 kilogram one is the cheapest. We've got a regular polygon has n sides. The interior angle of the polygon is 15 times its exterior angle. So if the exterior angle is x, the interior angle is 15x. Let's just have a reminder of what the interior angle and exterior angle are on a polygon. This is an unfinished regular polygon. Here is our interior angle. Exterior angle is made from a straight line drawn kind of along next to your interior angle. Angles on a straight line add up to 180. Divide both sides by 16. 11.25. There are some certain formulas you need to remember for this topic. One of them is exterior angle equals 360 divided by number of sides. I'm going to times both sides by n. Divide both sides by 11.25. Just gives you N is 32. Polygon has 32 sides. Write the following in order of size, smallest first. Let's convert them all to decimal form. Calculator paper, just type this into your calculator. 2 to the power negative 2, 0.25. Again, you can just type this into your calculator, or this is in standard form. When you're timesing by a negative power of the 10, it means you're dividing by 10. So 2 divided by 10 divided by 10 gives you 0.02. So our smallest. The price of a television is increased by 35%. In a sale, the new price of the television is decreased by R%. The overall percentage increase in the price of the television is 16.1%. Find the value of R. So I'm going to look at this question using multipliers. If you increase something by 35%, so adding 35% to 100%, we have 135%. What is that as a decimal? 1.35. We've times it by a multiplier of R%. Oh, that's not mine. I'm going to just call it X% for now because it's not the same. So that's the multiply of my decrease. And we get an answer of, well, an overall percentage increase of 16.1%. What is this as a multiplier though? If we add 100% to it, we have 116.1%. Change it to a decimal, 1.161. So I've just divided that by 100. So this X% shouldn't have a percent with it. Just the multiplier is not a percent. It's a decimal value of the increase as a percent. Anyway, let's get X now by dividing both sides by 1.35, which is 0.86. Now that's my multiplier. Let's times it by 100. 86% of something though is a decrease from 100%. What's our decrease from 100%? Well, 100 minus 86 is 14%. So that is the decrease R. Sasha and Taylor each have a stamp collection. They organise their stamp collections according to where the stamps come from: UK, EU, other. The table shows the number of stamps in each collection and the ratio UK to EU to other. When they put the two stamp collections together, Sasha and Taylor claim that at least 2/3 of all the stamps come from the UK. Are they correct? Show how you decide. Okay, we'll need to work out how many UK stamps they both have, first of all. So for Sasha, how many parts does she have in her ratio altogether? She's got 14 parts, because 9 plus 3 plus 2 is 14. Each part is worth 117. 9 parts are from the UK, so 9 times 117. So Sasha's got 1,053 UK stamps. Something similar for Taylor, 680 divided by the total parts. 8 parts are from the UK. So in total, the total amount of UK stamps they got, if they put the collections together, add these two values together, and we get 1,533. Okay, the total stamp collection, how many stamps would they have in total? 2,298. I'm going to work it out as a decimal. I know 2/3 is a decimal is 0.6 recurring. 2 divided by 3 is 0.6 recurring. Okay, so what about if they put their stamp collections together, we'd have 1,533 over 2,298. Which is 0.667, yes, which is close enough. So are they correct? Yes. They say at least, don't they? So at the minimum 2/3, yes, because that's slightly over 2/3. Or I might say actually 66.7%. We compare it as percentages. And here 2/3 is 66.6 recurring. So it is at least 2/3. Okay, we've got a question here. You are given y is proportional to x, y equals 9, when x equals 2. Find a formula linking x and y. So their solution is y is proportional to x, so y is equal to x plus c. Well, I can see a mistake there, because if y is proportional to x, y is equal to kx. I know they've used a c, but they haven't times it, they've added it. So y equals x plus c should be, it doesn't really matter what letter you use. Okay, so a correct solution, so when y is 9, x is 2, divide both sides by 2, k is 4.5. So we replace our k for 4.5. There's our solution, or formula linking x and y. A student attempts 2 tasks. The result of each task is either pass or no pass. Probability of the student passing the first task is 0.6. Probability of the student passing the second task is x. Complete the tree diagram. Well, each branch needs to add up to 1, which means this no pass would be 0.4. Same with the second task. Each branch has to add up to 1. If this pass is x, no pass is 1 minus x. X, 1 minus x. Write down the mathematical assumption that has been made about the 2 tasks. So our assumption is that the events are independent. The second task is not affected by the first task. Probability of the student passing just one of these tasks. So here is pass 1 task, you've gone pass, no pass. And here is also pass just one of the 2 tasks, because no pass pass. So we know 0.6 times 1 minus x. And this probability here is 0.4 times x, which is 0.4x. So we know if we add those together, we get 0.528. I'm going to solve to find x by expanding my brackets first, by multiplying everything by 0.6. Minus 0.6x plus 0.4x would be minus 0.2x. I am going to subtract 0.6 from both sides. Don't forget, if you subtract 0.6 from both sides, that negative needs to stay with 0.2. Now I'm going to divide both sides by negative 0.2. negative 0.072 divided by negative 0.2 gives you 0.36. Okay, we've got circle theorems. We've got P, Q, R, and S are points on the circumference of a circle. Centre O. Angle SQR is 14 degrees and SPQ is 62 degrees. Okay, brought over the circle theorems, the non-tangent circle theorems to help us with this question. So let's just have a look at all of these separately first. Have we got an angle on a semicircle is 90 degrees? Well, there's no diameter, so we do not have that one. Do we have the angle at the circumference is half the angle at the centre? Well, we've got an angle at the centre coming from the points R and Q. So we do have an angle at the circumference here. That's kind of like that theorem in disguise, because the circumference is kind of pushed to the side. Usually it looks more like an arrow. But what you've got to also look out for is you've got an angle at the centre, which we have, and an angle at the circumference that we have coming from those same points, Q and R. So yes, we do have that one. Do we have this angles in the same segment? No, we don't. Some people think we do here, but that all the corners don't touch the circumference, so we don't have that one. Do we have a cyclic quadrilateral in here? Yes, we do. So let's start out with this one. So, what angle do we actually need to find here? ROQ. ROQ is that one there. So using our cyclic quadrilateral, this opposite corners add to 180. So this one here is 118. So SRQ equals 180 minus 62, which is 118. Okay, then I've noticed we have a triangle here. Angles in a triangle add up to 180, which will help us find this one, QSR. So 180 minus 118, take away 14. 48. Then we use angles at the circumference is half the angle at the centre. So if this one here is 48, the angle at the centre is double. So ROQ equals 2 times 48, which is 96. DEF are points on the circumference of a circle. Line GH is tangent to the circle at F. Line DE is parallel to line GH. Complete these sentences, these statements to prove that triangle DEF is isosceles. Give reasons for your answer. So because we have these parallel lines, I can tell that these angles are the same because they're alternate angles. So EDF is equal to GFD because alternate angles. Also, we've got a circle theorem here. We've got the tangents here, which touches this triangle inside the circle, which means that this angle is the same as this angle. So we can say that HFE is equal to FDE. And our reason is alternate segment theorem. well, just thinking that's not actually that useful, but it is on the other side. We can say that GFD, so this angle here, is the same as DEF. And the reason is alternate segment theorem. We only really needed that bottom one. So now you can see that angle FED, FDE is the same as angle DEF. So I'm saying I proved that this angle is the same as this angle here. So it's isosceles. So that should have been confusing, these lines here. This should be here. Triangle DEF is isosceles because FDE is equal to angle DEF. Okay, function A and function B are shown below. The output of function B is x. Write an algebraic expression in terms of x for the inverse of function B. So going back the wrong way through a function machine, so we need to do reverse operations. Opposite of subtract 3 is plus 3. Opposite of times 5, divide by 5. So x plus 3 all over 5. Function C is shown below as a composite function. So it's made of two functions, function A and then function B. Complete the diagram below using two arithmetic operations to show function C is a single function. But I'm going to do it algebraically first. So my input was x. Put that in function machine A, we get x plus 2 times 3. Let me just simplify that by expanding the brackets, 3x plus 6. We now put that expression into function B. So 3x plus 6 times 5 minus 3. Let's expand the brackets and simplify. 15x plus 30 minus 3. Simplified gives us 15x plus 27. So what are we doing x here? With x, we're timesing it by 15 and adding 27. So times 15 plus 27. Question 14. The diagram shows a circle, centre O and radius 52. AB is a chord. So here's our chord of the circle. The line through T is a tangent. So this horizontal line at the bottom is, so the chord is parallel to the tangent, okay? Perpendicular distance between the chord and the tangent is 72 centimetres. Calculate the area of the shaded segment. At some point, I'm going to need the whole area of the circle, well, which we can work that out quite easily. Pi times 52 squared, because the area of a circle is pi r squared. 8,494.867. Okay. It'd be useful to get the area of this triangle here. How do I get the area of a triangle? Well, I could do half AB sine C, which should be given in your formula book. You could do half base times height. We don't know the base. The base would be AB. We don't know the height. We don't know this angle. But I've just noticed I can work this vertical length of the triangle because it's 72. Take away 52 because that is a radius there and that is 52 centimetres. So 72 take away 52 is 20. Because that's 52, so this has to be 20, the height of the triangle. Which means then that right angle triangle here, I'll just take it out. We've got height 20. I'm going to call that angle X, so that's the adjacent. 52 is a hypotenuse. SOHCAHTOA, adjacent hypotenuse cos. Cos X equals adjacent over hypotenuse, 20 over 52. Cos to the minus 1 both sides. Gives us our angle 67.38. So that angle there, 67.38. I can double that to get the whole angle here. 134.76 degrees. So now I can do half AB sine C to get the area of the triangle. Gives me 960 centimetres squared for the area of the triangle. I'm now going to work out the area of the sector of the circle here. Sector area is theta over 360 times pi r squared. In this case, my theta is 360 minus 134.76. I know angles around a point add to 360, so that angle there is 225.24 times pi times 52 squared. 5,314.955. Okay, so the shaded segment there is the whole circle minus the triangle minus the sector. Solve by factorisation. There's a few different ways of factorising when the coefficient of x squared is bigger than 1. I'm going to use the splitting down the middle method. So 3 times negative 8 is negative 24. So I'm looking for two numbers that multiply to give negative 24 and add to give 10. 12 and negative 2. I'm going to split down the middle. 3x squared plus 12x minus 2x minus 8 equals 0. I'm going to factorise. Factorise the left-hand side and the right-hand side. Bearing in mind I do want the same thing in all my brackets. So we'll have 3x minus 2, x plus 4 equals 0. X is minus 4, or x is, let's just put that bracket equal to 0. add 2 to both sides, divide both sides by 3. We want to complete the square with this expression now. So we halve the 8, x plus 4 all squared minus 16. 4 times 4 is 16. We've created that 16. We don't want it. Plus 11 simplifies to x plus 4 squared minus 5. Write down the coordinates of the turning point of the graph y equals x minus 3 squared plus 8. So we flip the sign for the x coordinate. That's our y coordinate. Describe the single transformation which maps the graph of y equals x squared onto the graph of y equals x minus 3 squared plus 8. So here we're subtracting 3 inside our function, which means a movement of 3 to the right. So it's a translation because we're moving to the right 3. And then we go up 8. We're adding 8 outside our function. So plus 8 means up 8. A lift can travel at a maximum speed of 9.83 meters per second. Correct the 3 significant figures. So already I can tell this is an upper bound, lower bound question because it's been rounded. The lift travels at a distance of 174 meters. Correct to the nearest meter between the ground and the floor. Use the information to work out the shortest possible time for the lift to travel between the ground floor and the top floor. Okay, so it's speed, distance, time as well. And so we know speed is distance over time. We want to work out shortest possible time. So we need to make t the subject by times in both sides by t. And then dividing both sides by s. So time is distance over speed. I'm just going to get my upper bounds and lower bounds. So my lower bound here would be 9.825 and your upper bound would be 9.835. Your upper bound and lower bound for 174 would be 173.5, 174.5. Shortest distance, so I want the smallest answer. So I need the smallest divided by the biggest. I want the smallest distance divided by the biggest speed. So the answer is 17.6 seconds. Explain why your answer to part A may not be possible to achieve. Or the lift could slow down and speed up. Question 17. The box plot shows the distribution of the waiting time of cars at a road junction. Write down the median waiting time. The median is here, 40 seconds. What percentage of the wait times were less than 30 seconds? So each bit of your box plots is 25%. So 25%, 25%, 25%, 25%, because it's your lower quartile. Median, it's the lowest, shortest time, lower quartile, median, upper quartile, and maximum time. So it's split into quarters, so it would be 25%. Given that a randomly chosen car waited for more than 30 seconds, write down the probability that the car waited for more than 90 seconds. Okay, so for this question, we don't know how many cars there are, but if we can deal in proportions, So we know the chosen car waited for more than 30 seconds. So it's out of like 75% of the cars, or 0.75. Probability that the car waited for more than 90 seconds. Well, a quarter of them waited for more than 90 seconds. So a quarter is 0.25. 0.25 divided by or over 0.75 is your probability. 1/3. Question 18. The graph shows the speed of an object during the first 20 seconds of its motion. Calculate the distance travelled by the object during the first 20 seconds. Okay, so we've got a speed time graph here. Distance is the area under your graph. It's a trapezium, or you can split it up into two triangles and a rectangle. So it's half times a plus b times h, a plus b, your parallel lengths. So it is the top one, it is 1, 2, 3, 4, 5, 6, 7. So you've got 7 plus 20, and your height is 12. So 7 plus 20 times a half times 12 gives you 162 metres. The graph shows the distance travelled by an object during the first 4 seconds of its motion. Work out the average speed of this object between 2 and 4 seconds. Right, so once it between here and here. So we need the gradient of that line in effect. So it's over 2. Rise over run. Height over base. And 32. Let's get an exact value here. 32 minus 4 is 28. 28 divided by 2 is 14 metres per second. Use your graph to estimate the speed of this object at 3 seconds. Got a curve, distance time graph. You need the gradient of the curve. So we need to draw a tangent at that point 3. We've got 1 as the base. 14 is the height. 14 divided by 1. Yeah, so we get 14 metres per second. Explain what happens to the speed of this object during these 4 seconds of motion. So as you can see from the graph, the speed is increasing. How do we know this? Because the gradient is increasing. Show that root 3 plus 2 over root 48 minus 6 can be written in this form. So we want to rationalise the denominator. So I'm going to times both of them by root 48 plus 6. So we now have double brackets on the top and the bottom of our fraction. If I multiply out the brackets on the bottom, root 48 times root 48 is 48. We're going to have plus 6 root 48, which is going to cancel with a minus 6 root 48, all over minus 6 times 6, which is negative 36. And at the top, root 3 times, we've got to show all of you working out here. The root 3 times root 48. 3 times 48 is root 144, which is 12. And I'm going to have plus 6 root 3 plus 2 root 48 plus 12. Simplify the numerator. We get 24 plus 6 root 3. I'm just going to simplify my root 48. So I need a square number that divides into it, 16. 48 divided by 16 is 3. So we can split it into root 3 times root 16. Root 16 is 4. 4 times 2 is 8, so 8 root 3. So plus 8 root 3, which simplifies to 24 plus 14 root 3. On the bottom, the denominator, 48 take away 36 is 12. Now we can divide through everything here by 2, which gives us 12 plus 7 root 3 all over 6.